Hi guys, we're going to be looking at variables and data types today. These are two very fundamental concepts in any programming language, not just Python. And these will be the very building blocks of everything you do in coding. So when you start to talk about different kinds of data types, you're talking about the actual kind of data that you're going to be representing in your program. And we'll get into the details of the different kinds of data types that can be used, and then how you can use those to assign to something we call a variable. And that variable can then be useful for having varying types of data in your program. So let's go right into the different kinds of data types that are available in Python, and these would be true for most programming languages as well. When we talk about data types in Python, there are essentially four kinds of data types that we can represent in Python. Now, some of these might seem redundant, but we'll talk about the nuances of these as we get through them. But for now, let's look at the first one, which is Boolean data. Now, Boolean data represents data that is true or false. Now, inside of your computer, you have a combination of ones and zeros. Everything on your computer is some kind of binary data, and that is represented by a bit. A bit is a value that is either 1 or 0. And a Boolean is an expression of that, where we interpret that 1 as being true and we interpret the 0 as being false. Now, we're not going to focus a lot on this today, but it's important to understand the concept of Boolean data because it helps control the flow of programs, and it becomes a very important concept when we start to talk about conditions and loops. But for now, just think of a Boolean as a representation of something that is true or false, and that it will be good enough for today, but we'll be using it in future lessons when we talk about conditions and looping. The second kind of data that we can talk about in Python is string data. Now, string data is essentially text data. Now, strings can be used to represent a number of things inside of a computer program, and we'll get into some of these in future lessons, but the primary way to think about string data is just text data. And we've seen an instance of this already when we did our challenge last week. We did Hello World in multiple languages. What we were doing there is you're taking some kind of text and we were putting quotes around it. And then by doing that, we were creating strings. Whether you knew it or not, that's what you were creating. Now, a string takes its name because it is a string of characters. Take the word BAD or bad. That has 3 characters that compose that word, B, A, and D. And I string those together and I create the word bad, and that is represented by string data inside of a computer program. And as I mentioned, you can use a string to represent lots of different kinds of things in a computer program. For instance, emojis. If you're getting a smiley emoji inside of a text message, it's usually represented by some kind of string data that has a special character that is corresponding to the smiley face or the frowny face or the poop if you want to go with that emoji. But in any case, the string data type is one of the most versatile data types inside of programming, and it can be used to represent all kinds of different things. But for now, think of it mostly as text data. The third kind of data that we're going to talk about is numeric data, and there are 2 principal kinds of data types in Python that are numeric. And you might be wondering why there are 2 different data types, and I'll get to that in just a second. But for now, the first one is integer data. Now, integer data is data without decimals attached to it. So think about your counting numbers, 1, 2, 3, 4, 5. This would also include 0, -1, -2, and -3. So basically anything that doesn't have a decimal is going to be an integer. And the second kind of numeric data is floating point data. The reason it's called floating point is the point or the decimal can move inside of that data type. So if I have 12.52, or I could have 125.2. The decimals move to the right in one place. That's why it's floating point. And floating point data is decimal data. It's much more complex to represent inside of a computer than integer data is. Every computer, every CPU that you have, whether it's in your phone, whether it's in your laptop, it has special circuitry that is designed for integer calculations and a separate set of circuitry that is designed for floating point data. And integer data is much simpler to handle, therefore it's going to execute much faster inside of your computer. And floating point data has to use that much more complex circuitry, therefore it's going to execute much more slowly in your computer. So the general rule of thumb is to prefer integer data where you can, and if you need to, you can use floating point data, and in that case you would assign something to floating point data and it will be able to be delegated to the appropriate circuitry inside of your computer. So in review, we have Boolean data, we have string data, and we have integers, and we have floating point. Now, we're going to get into the details of Boolean's data later on, and we're going to be talking more about numeric data next week when we talk about operations. But keep these basic data types in the back of your mind because they will be very important in programming from henceforth. And any kind of programming language doesn't have to be Python, but these are the four fundamentals that we're going to be talking about with Python. I want to introduce two more concepts before we go to the IDE. I will get there, I promise. And these are the ideas of casting and the type function. Now, casting is the ability to convert between different kinds of data types. Now, this is important to understand because inevitably you're going to be getting data in some kind of form that might not be useful for what you need it for. So you need to convert it to another kind of data. For instance, I might get some kind of data that is string data, but inherently what is represented in that string is some kind of number. And I need to convert that to, say, something like floating point data so I can do some operations on it. And that concept is what we call casting. Now, inevitably with casting, you might end up with some kind of data loss. For instance, if I was converting from a floating point number to an integer, I'm going to lose the decimal. So if I have a 1.111, I'm going to lose the decimal and everything after that if I convert that to an integer. However, sometimes with floating point, I can actually represent an integer-like data with that floating point. If I had 1.0, that is technically floating point, although if I converted it to an integer, I'm not really losing anything by converting that to an integer because there's nothing in the decimal that is really meaningful or that's going to alter the value of what is represented by that floating point number. Inevitably, though, you have to be careful when you're doing conversions, though, because sometimes data loss can happen. Now, some examples of this would be what we see here on the slide where I have int, and then I have open paren, and then I have inside of that some kind of string data, in this case 1, and then I close up that quoted text, and then I put a parenthesis around it. That's a function that will take the string data and convert that to an integer. So in this case, it's converting a string that has 1 in it to an integer, and I would expect that to give me back a 1. And the second example there, I have string str, and I open parens and I put in 1.0 and I close paren. So 1.0 is floating point, and by putting str around that, I'm converting that floating point into a string, and that is some examples of casting that we see there on the slide. And we'll look at this in action when we go to the IDE. Now, there is a function inside of Python that is specifically designed for detecting what kind of data type that I'm working with. Now, this becomes important when we do more dynamic type programming. We're not going to get into it a lot for this session, but it's important to know that this function exists so that you can determine what kind of data am I dealing with. Sometimes it's good to be able to test for the data type. That way we can do a appropriate conversion to it. And we will look at how to do that in future lessons. But for now, just remember the type function will return some kind of information about what actually I'm dealing with in the data type that I'm looking at. So let's go to the IDE and look at these different kinds of data types, and then we'll run the type function against them and do a little bit of casting so we can see how this works and get some experience of it just by watching. And then we will come back and look at some different concepts going forward. I'm here in Tony now, and let's do some code demos here. Let's make this a little bit bigger, and let's make the view a little bit bigger so that we can see this a little bit better on the screen. So first thing I want to do is just print a string, which we've seen already. Hello world. How about that? And we're probably sick of seeing that by now, and that's just simply going to print a string data type. So another thing you can do inside of code, and this is very useful for making your code more understandable, is commenting your code. So I'm going to say prints hello world. And this is a comment. This is a human readable comment, and I can put anything after this that I can put in my program to make me be able to understand what I'm actually doing in the code a little bit better than what I would if I didn't have comments. The compiler simply ignores that. That's simply whenever I'm looking at the code, I can see the comments in the code so that I can see them in line with the code and better understand what is going on with the code. So commenting your code is a very good practice. I would recommend start doing it now so that you can get in the habit of doing it, so that whenever you start programming much more complicated programs, you can comment them so that you can remember what you're doing in the code, because it's not always clear when you're actually looking at code. So I'm going to do a print, not print, an integer, and I'm just going to print an integer, and that is simply going to put in 1. So print can actually handle more than strings. It can handle multiple kinds of data, so it has the ability to interpret what you're putting into the print function and be able to print the appropriate value regardless of the data type that you supply it. So in this case, I'm going to print an integer, in this case 1, and we would just expect that to put hello world and 1 on the screen. Now if I did a floating point, I can do print a floating point. We would expect that to print a decimal after the 1. So we have 1.0, and like I said before, print understands floating point as well as integers as well as string. So we can see it print hello world 1 and then 1.0. Another thing you can do with a function, though, is you can actually put in functions inside of functions and make those kinds of calls as well. So what I'm going to do in this case is I want to do a cast and then print the results of my cast. So let's do this. Cast from, let's cast an integer to a float. So to do this, I'm going to do print first. I'm going to open up my parentheses, and then I'm going to type in int, float, because I'm going to be casting an integer to a float. And float is the function that I'm going to call, and I'm going to put in an integer into the parameter that is going to be passed into that float function. And then I'm going to close that up, and then it's going to print that to the screen. So it's not going to print 1 in this case. It's actually going to print a floating point number. So if you guessed, it's probably going to look like this. So if I go like do a run on this, I'm going to see it print out 1.0 for this particular command that I'm running here. Likewise, I can do a float to an integer, but in that case, as I mentioned, we're going to lose data. So basically I'm just copying and pasting things around here, which is something that you want to get used to, because in programming, sometimes you will have code that you already have and copy and paste it and modify it to your liking for your particular purpose. So I basically took this, copied and pasted it down here. Now I'm doing an int cast here, and then I'm going to print that to the screen, but instead I'm going to put in a 1.2 here. Now, because this is an int, it's going to drop the decimal, and it's going to drop anything after the decimal and simply return an int. So it should just be like this right here, which we've already seen. So let's go ahead and run that. And as we'd expect, it's just dropping the decimal and anything after the decimal in that conversion. So I'm losing data when I'm casting from a float to an integer. But you can also do different kinds of casts, say from a string to an integer as well. So let's go like this. Let's say string to an integer, and let's put in str, and I'm going to put inside of not string, int, and I'm going to put inside of my quotes here a 1, and what I want it to do with this string is cast it to an integer and then just print that to the screen. So let's go ahead and run this cast and see what happens. And as we would expect, it's doing 1 to the screen after it takes that string data and puts it onto the screen. Let's try and do a floating point representation inside of a string here and run that and see what happens. And now it's going to give me an error because it cannot interpret that as an appropriate integer, because that's actually floating point. It's not able to convert this, and therefore it's going to crash the program. It's an error. So that is invalid data for casting from strings to an int. So I need that to be an integer like that. However, if I took that same code and put it down here, let's go cast from a string to a float, I can then put in 1.2, and that should be, oops, I forgot to put in float right here. That should work. And if I spelled it right and run that, and we should see 1.2 as we'd expect, because 1.2 is, although it's a string, the cast understands that as floating point data, and it can then appropriately cast that back into a float and then print that to the screen. So what we see here is simply printing a string. We're doing some printing of some data types here that aren't strings. We're doing an int and then a float. And then here we're doing some casting. And then down here we're doing some more casting as well. So let's do some types as well. Let's look at the type function here. So I'm going to take this same basic construct and let's do type of data. And let's see what this comes back as. If I do type here, although this is a 1.2, because it's in quotes, it's going to come back as a string. So let's run this. And we should expect that to come as a string right here. So we can see, say it's class string. We'll talk about classes are in future videos, but for now, understand that this is what this is spitting out is an str that is string data because it's got the quotes around it. It thinks that's string data because it's being represented as such. However, if I was at first to embed a float around that, and now I have a function inside of another function here, I can then run this and it's going to still give me something a little different here. It's going to give me float because I have a float cast from a string, and then it's going to give me the type of that float. So to simplify this so that it might be a little bit, this might be a little bit much to take in, I'm going to take out the float here, the cast inside of this type, and just simply put in the 1.2 inside of our type. And that will also return me a float as well. So as we'd expect, type of data there. And then, of course, let's get an integer for good measure because I don't want to leave out integers either. And if I do a type around just a plain one, it's going to give me an int. And let's do, just for good measure, don't want to neglect the Boolean. Let's put in false and run that. And it's returning a bool. So we can see where type on true and false runs a bool. Now, let's do another interesting case here around Boolean as well. And that is using bool as an integer. And what I want to do is cast an integer to a bool. I want you to see what happens. And let's do this right here. Bool casting integer to bool. And let's do print. And then let's do bool and 1. And what this will do is it should print true because this is 1. And let's print that out. And notice what it did there. It's true. If I put 0 in there, the same code, I change that to 0, it's going to present that as false because it's either true or false. 0 is false. Anything else, let's say 5, is going to be true. So if I run that, it's going to represent 5 as true. So think of a Boolean as anything other than 0 as being true and 0 being false. Because ultimately doing this cast is actually losing data, but it's interpreting anything that is anything other than 0 as being true and 0 as being false, as we saw there. So that's several examples of different kinds of casts and different kinds of data type that are being used in this code. Now, I know it's a little bit to take in when you see this in the code itself. I will put this code up into a repository so you can actually look at it and review it so you can get some examples of how to do some casting and so you can understand what the data types are and what those look like inside of your code. The next key concept to understand in coding is variables. Now, a variable is something that we store inside of your devices or your computer's RAM. So all devices typically have two kinds of storage. You have what we call volatile storage and non-volatile storage. Now, non-volatile storage is where all the programs are stored. It's where all your files are stored. It's where the operating system of the device is stored. And it is what is there to allow your data to persist whenever you turn the device off. So this would be like the hard drive inside of your computer, or maybe it's the flash flash module on your phone, but if you turn that device off, it loses power, whatever it might be, that data doesn't get wiped out because it is stored on a non-volatile storage. There's another kind of storage on your device called volatile storage, or sometimes called RAM. And this is typically the smaller number if you're looking at the specs and you see storage on your device represented by numbers. Typically on a phone, it's somewhere between 4, 8, or 16 gigabytes. And on a computer, it might be 8 or 16 or 32 gigabytes. And the amount of RAM is determined by the amount of RAM that's baked onto the actual RAM modules in your device. And this is volatile storage, meaning that whenever you turn the device off, it gets wiped. The difference, though, with this kind of storage is that it's very fast storage, so it's going to be much more conducive for programs that need to store something in a way that's temporarily there, but that can be accessed and modified rather quickly. And that is much faster than doing it off something like a disk or off a flash module that is very slow relative to the RAM on your device. And so this kind of storage is where we write our variables to. We'll talk about file storage in a future lesson, which is where you can write it to persistent storage. But for most of the kind of stuff that you write in programs, you're going to be dealing with something that is written to your RAM on your device, and that is done by way of a variable. Now, a variable takes its name because it can change, it can vary. Now, if I create a variable in my program, I can then operate on that variable, read the data out of it, or I can change the data in that variable, and that allows my program to have dynamic behavior. So I can have, say, a print statement that has a variable as its parameter, and that variable might have different values depending on when I call that same piece of code over and over and over again. But the variable allows me to change the output. So I might have the variable that has the value of dog in one case, I change it, and then I call that same print command later on, and the value is now cat. It would then print out cat in that case. And we'll look at the ability to change variables here in a second when we go back to the IDE. Now, variables can take on any kind of data type that we've seen already. So you can have Boolean variables, you can have string variables, integer variables, and you can have floating point variables. You can change the values of those and then do something with them as well. And here's some examples of what these might look like inside of code, where we have a variable called val1, and I assign to it a value of 1, and it's not a floating point number, it's a integer. So this is an integer variable that has the value of 1. Another might be val2, which has, in this case, quoted text, which I know is a string. So I'm assigning Blaze to that particular variable. So I'm here inside of Tony now, and I want to demonstrate the ability to create and change variables here. And I want you to pay attention to this tab up here where I have variables. This is where this becomes pretty handy inside of Tony, because it's another feature of Tony that will show you the name of a variable and the value of it. So let's do a variable here. Let's call it val1, and that's going to be my variable name. And then I'm going to say equals 1, and then I'm going to print val1. So I'm creating a value variable, essentially an integer variable here, and I'm going to print that to the screen. And let's run this, and we should see up here now variables, val, and the value of 1. So like I said with variables, is you can change their values. So let's copy and paste this code, and let's change this to 2 right here and print that out. So let's run this again, and it's going to show me the value of 2, but here's what I'm going to do this time. And instead of just running the program, I'm going to put it into debug mode, and I'm going to step through the program, and we're going to watch the value change over here. So let's put it into debug mode, and I'm going to run this line of code first, and notice that I put val1 over here. Now let's print that value out. We saw that down here in the shell, and then I'm going to run val1 again, alter its value. Notice that it's 2 over here, and then I'm going to then write that out down here to the shell. So here we can see where we have a single variable that we have changed the value of it twice. We assigned it, we created it and assigned it, and then we changed it right here. So this is why variables are so powerful, is because we can change the value of it, but run essentially the same command and get the different kind of result based on what I put into the particular command that I'm doing here. And this parameter is no longer hard coded. It's an actual variable that I'm passing into the print command now instead of a hard coded string or a hard coded value that we've been doing up to this point. So these are integer variables. There's another thing that I want to show you that is the ability to change the data type itself of a variable as well. So with Python, we call it a dynamically typed language because it allows me to change not only the value of a variable, it means I can change the type of the variable in the code as well. So let's take a new variable, let's call it num1, and I'm going to assign it as a float. So it is 1.0 for the value. And if I do a print on that, let's do print num1, and we would expect that to be 1.0 down here in the console or in the shell. I'm also going to do a print of the type of num1 just to show you that it is a float whenever I print this. Now, because this is dynamically typed, I can, like I said, I can not only change the value, I can change the data type as well. So let's remove the 1.0 and let's just change it to an integer of value 1. And if I do a print of that num down here, I'm going to get 1, and then I'm going to get the type of num1 as well. So let's run this. I'm going to put a breakpoint right here, and let's debug it, and it should stop right here on that line. And now I have my value 1 already assigned. Let's step over this. Now I have num1, a value of 1.0. This is floating point now. Remember, I have a decimal and something after the decimal. And I'll print the value down here, 1.0, and I'm going to print the type. Notice it says float. Now what I want to do is change the value and the type in this line of code right here. And notice that it changed the value right here up here in my variables. I'm going to print the value down here inside of my shell, and then I'm going to print the type of that value. Notice that it's int now. So I not only changed the value, I changed the data type as well for this one as well. So this is what it gives me the ability to dynamically change the value and the type of the variable. Now I'm going to make that a comment, and in this case I'm doing it from a float to an int. And again, you can do the same thing for strings to ints, and then you could do the same things from a Boolean back to an int or whatever it might be. You can dynamically type these, and you can also change the values of them. So this is really the power of variables, because I'm able to change the values of them and run essentially the same piece of code over a new value and get different behavior from my program. Up to now, we've primarily been looking at programs that had all of the data hard-coded into the program. And even with our variable examples where we were creating variables and we're changing the variables, we're doing that by way of hard-coding the new values into the program. It becomes a lot more interesting, though, when you allow your user to input data into the program. And that is done by way of input. And today we're going to look at input from the keyboard. And Python has a special function called the input function that allows you to interact with your program in the side of the shell. So you can type in on the keyboard and get some kind of data from the keyboard and then bring that back into your program, and it's going to be back into your program as a string. And that string can then be assigned to a variable, or that you can also cast that to some other kind of data. Now, with the input command, I can type in any number of things on the keyboard. So I could type in ABC123, and if I try to cast that to, say, an integer, it's not going to work. So you have to be able to handle the ability to have this kind of input in your program. But for now, we're not going to worry about that in our examples. We're just going to assume that our user is going to type in good data whenever we cast it to other types of data. So we're going to ask them to input a number, and we want the user to actually put in a number. If they type in A, it will cause our programs to crash. We'll be talking about how to handle this in future lessons, but for now, don't worry about it. We'll get to that eventually. But if we're asking for string data, it can be practically anything they can put in on the keyboard. So we basically just want to be able to enable our user to type in something on the keyboard, and that's what the input function is going to do. And an example would be something like this, where I have name, and I ask, what is your name? And then I put in the parentheses on the input function, a string that I want to prompt the user for inside of my program. And then the user is going to type in their name. And then by using an equal sign next to name, I'm going to be assigning that string output from input into my string variable called name. So let's go over to the IDE and let's take a look at what this might look like in a program. I'm in a new file here and I want to create a variable called val1, and I'm going to start using the input function. I'm going to say type in something, and something with a G, and put a colon after that and a quote. I put the space there just so it makes the program look a little better in the shell. And then I'm just going to say not parent, print val1. And this is going to prompt the user for input on the keyboard, and it's going to print it back to the screen. So let's go ahead and run this script, and it should ask me for something down here in the shell. So hello world, and hit the enter key and it prints hello world. So very basic program. It just basically takes whatever I put in here, assigns it to a variable, and prints it. So let's make this a little bit more interesting, and let's type in something that is a number. So let's take this value here. It's going to ask me to type in something, and then I'm going to type in a number. And I want that number to be, let's say, not val1, let's call it num1 for my variable name, and num1 here. But what I'm going to do here is I want to do a cast on my input. So I'm going to convert this to an integer. So rather than say type in number, let's say type in integer right here. So this is going to take input right here from the keyboard, attempt to cast it to an integer, and assign that to this variable called num1. And then I'm going to print num1 back to the screen. And then, as you might expect, I'm going to do a type as well. And just to show you that it is an integer. First, it's going to prompt me for this, and then it's going to prompt me for this. So I should get two prompts inside of my little program now. So let's say type in something, hello. Notice that it printed hello this time instead of hello world, because the value of that variable is now different because I typed in something different. Now I'll type in an integer. I'm going to punch in 2, and it's going to print out 2, and it's also going to tell me that it is an integer. Now, if I run this again, I can type in something completely different. I can say goodbye, and it's going to echo goodbye back to the console. But let me put in some text data here, and it's going to give me an error because it was unable to cast that. And this is that ability to type in something from the keyboard. It comes back as a string, but I cannot convert it to an integer because of the kind of data that was input. So it only works if the user actually puts in good data. So for now, we're just going to assume that the user is putting in good data and they're not going to put in bad data. But that's a bad assumption for real world applications. You always want to handle the data and make sure that it's good before you try to do anything with it so your program doesn't crash like it did here. But we'll get to that eventually, so don't worry about that. But here we can see the ability to create variables by allowing input from the keyboard. So the last concept I want to introduce here is called string concatenation. Now, this is the ability to take two smaller strings and combine them to make a larger string. So basically combining strings. So let's say I had a variable called first name and its value is Blaze. And then I have a second variable that is last name and its value is Stuart. And I want to create another variable that combines these two together. So I call that name. I say first name plus space, which is that hard-coded space value there between the quotes, and then plus last name. So what this is doing is concatenating those three strings together. I have two variables that are string variables and then a hard-coded string to form a string that is name. And then if I print that, it would be the output of Blaze Stewart as the space there. So you can see there, it's a very basic example of string concatenation. Let's go over to the IDE and actually combine this with keyboard input so that you can see how you can actually type in values and then concatenate them together and then print them out. Okay, now I have a new tab up in Tony. I have my data type demos, I have my variable demos, my input demos, and I have a new tab here called concat.py. And this is where I'm going to put in some values to create a program that will allow me to essentially concatenate some strings together. So let's go ahead and do this. So let's get a first name variable, first name equals input, and let's call enter your first name. And that is going to be assigned as a string variable to first name. Let's do last name equals input, enter your last name. Now I have two variables here, and now I'm going to create another name called full name, or I could just call it name. And then I'm going to do string concatenation here. So I'm going to do first name and get the capitalization right there because that does matter. And then I'm going to put a space in there. That's a hard-coded string. And then I'm going to do another plus, and I'm going to do last name. Now what this is doing is, as you might expect, taking first name, concatenating it with a space, and then concatenating last name to it. And then I'm going to do print full name. So this will essentially prompt me for my first name, my last name, and then concatenate those together into my full name. So Blaze Stewart, and it prints Blaze Stewart out in the output in the shell. So again, very basic example for doing string concatenation here, which brings me to the challenge, which is going to actually be using this for the challenge. The challenge for today is to create a Mad Lib. Now, if you're not familiar with what a Mad Lib is, these are an old game that used to exist on paper before everybody had smartphones and things. I think you can even download apps for these now. But essentially what these games do is it prompts the user to input a bunch of nonsensical type things. So it's just random things like give me an object, give me a date, give me a name, give me a verb. And then you would write all of these down and capture that. And then you would read the story aloud, usually to humorous effect because it's usually utter nonsense. Sometimes the comic relief of these can actually make sense because of the scenario that you're imagining in your head. But regardless of what it is, I want you to create one of these using a program, and that program is going to be using inputs. So I want you to basically give me 5 inputs, and then I'm going to ask for a name and then concatenate all those together in a string and write that back to the shell. I'm going to show you an example here in just a second of what I came up with, and you can come up with a better example because I'm usually not that funny. But in any case, we'll do this for this challenge for this week. And for this challenge, complete the challenge and then submit it to me at coolenoughttocode.com/feedback, and then I'll put your name in a hat for a $10 Amazon gift card that I will draw out of the hat, and then I will announce that on next week's live stream, and you will be able to figure out if you won this little drawing by completing the challenge here. So again, a fun way to practice what we've learned, and there's a little incentive there if you want to participate in that as well. So let's flip over to Tony and I'll show you my example, and then you can have an idea what I'm kind of looking for inside of the code that I want you to write for this challenge. So I have here inside of Tony my challenge.py. I obfuscated it so you can't see my solution. That would make it too easy if you just copied what I did. But let's run this and I'll show you what I mean by a Mad Lib inside of code. So it's going to start with a proper name. So I'm going to type in a proper name. Let's call it Blaze. That's a proper name. A thing. I've got a coffee cup sitting next to me. Coffee cup. A unit of time. Let's say a second. And let's say another thing. I've got a screwdriver here that's sitting next to me. And a past tense verb, ran. So let's see what happens when I generate this Mad Lib. Blaze wrote a program about a coffee cup. That actually makes sense. The program ran for 1 second. That actually kind of makes sense too. And after it ran, the screwdriver ran. That doesn't make much sense, but okay, you get the idea. This is kind of what a Mad Lib does. And so you can imagine what this program might look like. Just to give you a few hints, I've got inputs for different variables here, and then I've created another variable concatenating those together. We're not really looking for any kind of typecasting here. We're not doing any kind of conversions here. I just really want you to work on getting keyboard input, assigning it to a variable, and then creating another variable using string concatenation and then printing that back to the screen. So that's the challenge for this week. And it'll encapsulate a lot of the things that we've talked about, including using data types, working with variables, working with input, and then working with string concatenation so that you can create something that's essentially like this program right here. So this is what I'm looking for in the program to give you an idea of what it's going to be doing. So submit the challenge to me and I'll enter you into a drawing to win a $10 Amazon gift card. So I hope to see you next time on Cool Enough to Code. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron, and there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.